Everyone, I wanted to go over the merge sorted arrays problem. It's one of the first questions in the top 150 interview questions. It's marked as easy and it is pretty straightforward, but I do think that the focus on updating it in memory can trip some people up, so I thought it'd be worth walking through. Let's jump into the code. All right, so looking at this, I have already written out kind of one of the test cases here and just wanted to talk through some of the logic. So one of the pieces that makes this unique is that you want to update the initial array with the values instead of creating a new array. This is so that you can not take any more memory than that already exists. And I think it makes this a little bit more interesting when you have to use two pointers to kind of keep track of both the initial array and the second array. So looking at this, you probably already know this problem, but just a quick overview. The first array is going to have the values that you would want and plus some placeholders with zeros. Then you have a second array and you want to sort them so that they are in order. So now that a few things to keep note of is that both of these arrays are already sorted. So we always know the last value, at least for the second array, is going to be the highest number. And because of the way this problem is structured, we already know the largest number in the first array given the index provided by m. So thinking through this, as you've seen, I've put some carets here to mark the different values. So the first, what I have highlighted here is the end of the first array, and then we have the second array here. The goal is to keep track of the last item in each array and go through asking the question, is this value more or less than the highest value? So for example, what we'll want to do in the first iteration, we'll want to look at 6 and 3, determine which one is larger, and place that number here at the end. From there, we'll move down the array and rinse and repeat until we have the new array. So let's jump into the function and figure out how we would want to do that. All right, so there are going to be three things we want to keep track of as we iterate through these arrays. One is going to be the largest number, which we know is provided by m. So we can call that n. We're going to call that n1. So this is for the first array. So numbers 1. We'll say it's m minus 1. We also need to do this for the second array. So we'll do n minus 1. And last, we need to know the full length of the initial array. So we can say, let's just call this index, since this is the entire array that we want to focus on, and we can make that m plus n minus 1. Okay, so from here, let's talk about how we want to loop over this. When we're looking at this, we want to make sure that both the n1 and the n2, everything has been included. So we can do this. n1 is greater or equal to 0, and n2 is greater or equal to 0. Then we want to work our way down the array. We've gotten to our first logic point where we want to ask, as stated up above, is 6 greater than 3? So to do that, we can say if nums2 is greater than nums1 by num n1, right? So this is comparing 6 to 3. If this is the case, which for us it is, we want to update the last point of the array. So we'll say nums1 index is equal to nums2 n2 here. So now this puts 6 at the end. Let's go update our example up here. So this is 6. And then from here, we now want to decrement nums2 n2. And the reason being is because we already took care of 6. Now let's move down to 5. So we'll say nums2 n, or we'll say actually just needs to n2 minus minus. So that changes the index. And doing that effectively moves this here. Okay. And we will also at the end, we'll decrement the other one, but let's do the opposite of this. So if in the case that the 3 is larger, we want to do the inverse of this. So nums1 index is equal to nums1 n1. And we want n1 to decrement. Now, after all of this is done, whether either of those cases are true, we want the index itself to move down so that we're going to cover the full array. So going through this, that last step will make this happen. And then we're going to rinse and repeat. Right, this is where the other case comes into play. Well, is 2 greater? We move down here. Okay, so now we have to ask, is 2 greater than 3? It is not. So now this becomes 3. And now this is going to be next lowest number. Is it? No. So what we're going to want to do is have this move here. And then we don't actually have to worry about 1 because we're just going to go, we know that that doesn't need to change. And so all is fine. There's one other case here that we want to make sure to cover. And that's in the situation where n2 N2 is not at 0 yet. So we've gone through all the initials, but we haven't hit the end of the second array. So we can say for N2 is greater or equal to 0. We will want to set N1 index equal to nums N2. And from here we can say we'll say N2 minus minus and index minus minus. Oh, forgot to put the 2 here. Okay, so this should cover all of our bases. I have some tests over here that should give us everything that we would expect, and we should see these work. Go test. Okay, and everything passed. Okay, just to reiterate one more time, this is going to keep largest number in initial array, length of second array, and then length of initial array. So doing this, we are keeping track of these 3 pieces of data, and then we want to loop over these. As long as there are still items in the array, whether it's being the largest number in the initial set or in the second array, we want to set these values accordingly in the first array and decrement accordingly. And then, of course, we want to continue moving down the initial array until all the positions are filled. And just in case, we have this here as well. We have this here so that if the second array still has items, or still has numbers to iterate through, we will set those accordingly and decrement just like we did above. All right, I hope that was helpful. I'll see you in the next one.